you've been enjoying the whole first day here and getting in lots of sessions. I'm really glad you were able to come here. Yeah, and there's a really hard choice having to make here at the end of the day. I wanted to mention, we've been doing this YouTube series as a countdown to SUGCON. We did 23 videos in a row just on architecture and scaling. If you haven't checked it out, go take a look. It's got lots of data flows in there. Our very own Thomas Eldblum did a great job pulling all of that together. And today we're going to take that series just one step further. It covered a lot of different things, and if I was going to go over everything that was seen in those videos, we'd probably be here for the next 4 hours. Some of you might shoot me if we did that. So we're not going to do that. We're going to focus in specifically on the XP services, and within that, specifically on the new APIs that came in St-Cyr 9. That's going to allow us to have a little bit of a fence around what we're going to talk about. But before I get into that, I want to address a little elephant in the room. Well, maybe a big elephant in the room. A lot of you have probably gone to several different kind of DevOps and architecture sessions before, and you've probably been in talks about that with your customers. And there's something comes up a lot, something we don't like to hear. It depends. Unfortunately, it does depend. Scaling is all about what does it depend on. There is no way I'm going to be able to tell you you're going to need 6 CPUs, about 64 gigs of RAM, and you're probably going to put 12 servers out there. I can't say that because it does depend. What you scale to is going to depend on your situation. What your situation is, what functionality are you using? What kind of visitors are you getting into? So what we're going to look at today is we're going to look at a few scenarios. We're going to look at the options so that what you're going to be able to do is then have a more educated discussion about how to scale your particular scenario. So let's get started on this. The first part of scaling is all the way at the back end with the databases. Whenever we get into any kind of chokehold with our performance, it often comes down to the I/O at the back end. So we're going to take a look at what those new XP services databases are. In here, we have a lot of stuff going on, but when we install as a developer, we tend to all see everything on our system all as one big, huge SQL Server installation. From here, you might put this out in a development environment or a test environment, and if you had a very strange production environment, maybe. But typically what we need to do first with databases is isolation. This allows us to maximize resource usage and dedicate the resources for writing and handling the operations as they come in. Now what we did here is we isolated out XDB. This is probably the first thing you're going to do with any of your installations. Collection does a lot of writing. It needs to be able to scale separately from everything else, and you don't want it interfering with the rest of your architecture. The other piece we do here is taking all the reporting and analytics stuff and shoving that over on a separate server. This isolation keeps all of that processing action that's happening, all the reporting action, from interfering with other pieces. You notice Core Master Web not up here. Again, we're focusing in on XP services. But what we're doing here is trying to isolate databases to allow us to scale. You may go another step further. You might want to go even further and say isolate all of these to their own SQL Server. But at the very least, this is the type of isolation you're probably looking at in most production environments. Now, one of the things that we could additionally do is with XDB, it has sharding. So what that means is that that one database is actually many databases. So you get to have this kind of distributed capability for your writes and for the storage. Now, why is it that the collection database is special? Why do we need to be able to do that extra level? This comes down to data growth. Now, these are kind of ideal graphs. Obviously, you're not going to have a straight, nice line for your collection coming in. It's probably going to be more of like spikes as you have traffic coming in. Maybe if you have a real viral campaign going exponentially. But the purpose of it is to show you that when you get into these different XP databases, it's the one you need to worry about. You might have, with reference data and marketing automation, a kind of initial surge that your data goes up when you're populating in all those marketing automation plans, all your marketing taxonomies, everything's getting defined up front. You kind of go up. After that, it's kind of the marketers are in control. They're defining new taxonomies, getting rid of campaign plans, adding new ones. All that stuff is going to allow for some growth, but compared to what's happening with collection, it's nothing. Every time your business goes out and brings in new users, and those users are doing new interactions and triggering new events, that's all going into XDB. And that's why we have to worry about the scaling on that particular database most of all. So I mentioned the sharding piece. So I want to go, how does this actually work under the hood so we can kind of understand where the problem is? When we go about doing sharding, what we want to be able to do is handle growth and be able to keep growing and redistribute the data. We base everything around the contact. So whether it's an interaction, whether it's an event, whether it's a facet, everything comes back to a contact ID. That contact ID we can then use to determine where it's going to go. By hashing it, we introduce a little bit of randomization. This allows us to then determine where it's going to go into the shards. A range map says, you know, if you're down on this low end, go into the first shard. Otherwise, the high end, let's go into the second shard. And on the diagram here, I have two models. One of which is the default, where you get 2 shards out of the box with your installation. The other one is you decide to scale out. Double out your capacity. Double out your write ability. You'll notice the ranges change. So you could imagine something that used to be in the high end of shard 0 suddenly in shard 1. This redistribution is not something that you can just hit a button and it goes across. I mean, you're talking about redistributing data. How does the application know how to get all this? On top of your shards, you have something that's in there called a shard database manager. The shard map manager is going to be able to be something kind of like this table on the left, where it defines, you know, what's the low end, what's the high end, and what server it's on. What's the database name? So not only are we distributing across different database for just the storage, we can change servers, which allows us to then scale out geographically. We can start doing a lot more with our data. We probably want to keep them generally close to each other, but it does allow us to get a lot more resources in there. So you can imagine a scenario where you just add another 4 rows in this table, and whoa, you've got new shards. A little more complicated than that in real life, and there's no, as I said, there's no easy button. It is something we're looking at roadmap-wise. Is there a way we can get this in there so that there's a tool for database administrators to just kind of be like, I want to remap this from 4 to 18, and have it just redistribute the data for you? But that's something that's going to come down the road. The other thing to take in mind here is, what are we going to do from how big this should be? Because theoretically, I could go put 64 shards out there and I'm all good. There is an underlying cost to that. Every time you have to go into the range, figure out where it is, go to another database server, figure out where all the data is, you are introducing a certain overhead, plus you're managing all those servers. It's a cost to it. So I wouldn't recommend necessarily going out and putting 64 shards out just because you can. I mean, if your performance requirements require that, sure, go ahead. But for the most part, you want to start small and then plan for growing over time. All right, what are our options on the web app side? So outside of the databases, we've got actual new web services that get deployed, as well as worker roles. We're going to start off talking about those web app services. You're probably familiar with XConnect. We've been talking a lot about that today. XConnect's just a part of these new services. And by default, when you go and put in like an XP single, it's all one big website that has everything configured on. Now, you could technically spread that out, install as separate websites all on the same server, but you're still resource locking there. But that would be kind of your base endpoint. The first stage of trying to get and scaling this out is getting XConnect separated from everything else. In almost all scenarios, XConnect is going to be your bottleneck for these. Unless you happen to be doing a lot more with the other services, it'll be your first point of scale. Beyond that, it's splitting out collection versus search. So the search is where we go and we'll do a lookup. We'll try to find a lot of contacts, try to figure out something that matches a query. This might get used by something like EXM or content testing. So it can get some load, but it doesn't necessarily get the same kind of load that collection does. And you want to have the flexibility to scale those out independently, put more resources on collections separate from search. So we do a little separation there. Now the team's looking at marketing automation. We need to give it some more resources. So we separate out the reference data, and now we can focus in on marketing automation, allow it to scale independently and isolate it. And of course, splitting those out from each other. Marketing operations, very handy for live events, whereas the reporting kind of services more the authors. Depending on what your usage load is of the live events versus your authors using it, you're probably looking at operations needing more scale. So we've talked so far, taking web services, splitting them apart to isolate and give them more hardware. You can obviously go on each one of these, vertical up, add more RAM, more CPU, but what you can also do now, every single one of these new services supports load balance scenarios. You can horizontally scale these out. That gives you the ability to choose which of them is really having a lot of incoming traffic and be able to have flexible options there to be able to handle it. Now, I haven't talked about those worker roles yet, so let's talk about those for a second. So first up, the search indexer. Its job is basically to look at everything in the collection database and put it in an index. So, depending on your scale, it's either doing it quickly or slowly. System's not going to fall over because it goes slowly. It's probably not something you're going to focus a lot of your performance time on. But there is something to note here. You can vertically scale the indexer. You can give it its own resource. You can have it as much RAM and CPU as you want. It cannot scale horizontally. You cannot distribute it with multiple instances. That's something we've got on the roadmap. We have no idea right now when that's going to happen. But right now, you've got one of these to work with. So it's something to think about when you're going through the scenarios we're going to talk about later. Marketing automation engine, on the other hand, a little bit different. So this one's in charge of the plans. It goes through, processes the work that has to be done, and then updates all the contacts and where they are in plans and make sure everything gets triggered. So it does a lot of work, but it does it very quickly. You can isolate it, you can give it the extra resources, but this one also supports the ability to go horizontal. You can have multiple of these. Now, I've been talking about these kind of as a Windows service with servers. In Azure, these are called web jobs. So you can also have them separated out horizontally in Azure. Lots of options. I know it's a lot to digest. I'm going quickly through this. My point was, we've got a lot of options there. We've given you the power to be flexible. You can go and choose how you want to do it. It's not that big monolith chunk where you're trying to figure out how you can service this little piece and you have to scale out the entire SUGCON instance for it. So we're making a more atomic infrastructure. As architects, that's great, we've got options, but that also makes us have a lot more to think about. It's a lot harder to get ramped up on it. And we don't necessarily have the history of putting in place flexible infrastructures that can adapt and use this kind of flexibility. I know you've been in a lot of talks that have been pushing Azure paths, and I'm only going to do a little plug there. The auto-scaling really does take advantage of this type of stuff. When we go and we build out these new infrastructure models, we are thinking about this and how can we leverage the tools that are being built out for cloud infrastructure so that we take advantage of the flexibility. So with that little sales pitch aside, scenarios. So what we're going to do here is I'm going to walk through a little story, and we're going to look at how each step of the story we can think about what the data flows are, which services get impacted, and how we might scale in that, just so that we can get kind of a grounding for you being able to go out and look at your own scenarios. And the first one we're looking at is the old Brochure website. This one, nothing but content. Basically, content delivery is doing all the work and servicing up from cache. We don't have any integrations, no advanced code in there. We're not really worried about anything. We're not running marketing automation or personalization. This couldn't be easier from an implementation standpoint. The only worry we have is that there's a lot of visits coming in. So let's take a look at what the infrastructure looks like. The first elements we're going to be working out is how does the end user get impacted by all this? A visitor comes into the site. They're going to get a session. This session is going to drive all the data about that contact, all the interactions they do during the entirety of that session. It's going to get stored there. Now, if we happen to know them, let's say we've identified them via email address or they're a returning visitor in some way, we need to go use the XConnect collection service. Go find out about them. What do we know? That gets put into that user session. And now we have some data from historical purpose that we can leverage later on. Something else the tracker does is it goes and looks at the reference data service. At this point, what it's saying is, hey, I've got some knowledge about the user, but what does this mean when it references this particular piece of metadata? Reference data stores that kind of metadata information, lookup tables and things like that. And it fills that out, and it's going to use that for the rest of the session. And now we're done. We know everything we need to know until that user leaves. When they do leave and the session ends, that's when we're going to write everything over into collection. So you can imagine, got a lot of visitors coming in. They're all doing this a lot, looking up their data, storing their data. The piece we need to worry about, XConnect collection. That's where we're going to need to scale out. We're talking about lots of visits, so we need horizontal scaling. We need to be able to handle multiple requests coming in. The XDB, similarly, we're looking at shards. Lots of data getting stored, lots of data getting loaded, so we need isolation of hardware to handle all the loads, and we need the isolation of hardware and extra shards to handle the extra contacts and interactions. But what about the other side of the thing? Data's in there, what gets triggered? We've got the XConnect index searcher here. It's going to go grab all that data and put it into the index. So now we have a decision we have to make. How real-time do we need this data to be? If we don't care, don't touch it. Let it go. The more you have some kind of system that's going to depend on that data being in, maybe it's a marketer wanting to be just able to look at the X profile and see what's happening, and they're like, where's my data? That's when we might have to scale this one up. And like I mentioned earlier, we can't scale it out. So we're looking at vertical scaling here, adding in enough power to be able to get as close to the real time that meet the requirements of whoever's trying to look at the data. The other piece of thing that happens whenever we get all this collected data, even if we're not using it, is aggregation. I don't want to talk about the processing role too much because it's one of the older services. It's not what we're going into. But it does touch on a lot of these services. When it starts getting all that data coming into XConnect, it gets triggered off and sees that there's something going into this XDB processing pools database. This is a new database that's in here that basically tells processing, you have something you have to go do. When it goes and grabs that new piece of work, it might hit out to XConnect, it might hit out to reference data, it might hit out to some kind of external service, but ultimately, it all comes down to the XDB reporting database. So we talked about earlier, why were we separating out reporting and analytics and processing? Well, here you've got data writes happening, both pulls, we got pushes coming from XConnect as it's capturing, and then in the end, processing's going into reporting database. And you don't want this stuff interfering with your other actions that are happening in the system. So if processing's doing a lot of work, you got to worry about those databases particularly. Okay, that was the easy one. Now, we're going to go back to something I talked about during the opening, the habitat with Vicky going into the store and the customers trying to get loaded, the profile there. So we've got this scenario with the data integration. We want to be able to take the customer profile, bring it into the store, and if something happens in store, like they purchased a new TV, we want Vicky's information to go up into the database. So we're going to use XConnect. We're going to use some basic custom trust client and a clientele and app. So how does this look like on the XP services side? The first thing that we're going to see is that it looks a little bit like our web visit in terms of the roles that get involved. The trusted client makes a call to XConnect collection, which in turn gets put into a database, and then the indexer goes to work and puts things into the index. So we have the same kind of concept. We have a lot of possible endpoints coming into XConnect collection, so we probably need to worry about horizontal scaling there. And again, how real-time does that data need to be? That's going to be on how much we want to push the XConnect search indexer. I would advise, if you're in this particular type of scenario, unless you have something in store that cares about what happened in the store, you probably don't need to worry about the real-time nature of this data. But if we're trying to have them leave the store, look at the website, and have what happened in the store reflected, then that has to run a lot faster. So that's when you're going to have to look at your requirements and say, again, how real time do we need to be for our scenario to make our customers happy, and start pumping up more power into there. Now on the back end, we talked about, that's basically pushing the interactions. A purchase happened. Now we got to pull. We have to find out information about the user. We're going to be looking up using the search. And this is the first time we've seen the collection search come up. Trusted Client connects, it looks data up in the index, fills it out with data from the database. At this point, we're pretty much done from a flow perspective. So it comes down to how many points are actually doing this pull. Do we need to horizontally scale search? If we've got a lot of trusted apps that are maybe geographically distributed, calling this in, we need to be able to handle those multiple calls. XDB probably needs to be scaled out again. We need some more power there. So this will be the point where we're, again, trying to scale out, meet that demand of calls. Now the next step. Marketing team's happy. They've got the in-store, they've got all the data being collected, they know what's happening offline and online. Sales team wants in on this now. They've got all of their information in Salesforce. They want to bring that into Sitecore, but mostly they want all that data that's coming into Sitecore over in Salesforce as well. So we're doing a two-way integration. In this scenario, we're going to do an hourly sync. You might even do like a daily sync, but the purpose of here is we're doing batch integration. Now you might be saying something like, Jason, why aren't you doing real time? Now this happens to be because it's Salesforce, and they've got an API limit. So when you're looking at doing something like this, you don't want to burn through all your Salesforce API calls, so you're probably doing a batch anyways. So I figured it'd be a nice realistic scenario for something you're going to look at. So far, we've looked at a lot of the services before that were involved in this. It looks, again, a lot like the flow we did before. This is on purpose. We're seeing a kind of repeated architectural style. We've got data exchange framework running underneath Salesforce Connect. It's pulling information out of Salesforce, telling XConnect, hey, here you go. Here's a big batch of data. Hey, search indexer, can you go put this in the index? All of this happening very similarly to what we just saw. There's a little delta here. What's happening here is happening in a batch. Even if you happen to be running the Salesforce connector with multiple threads, you're probably looking at like 20 or less. And you're not doing it in real time. So you don't need to worry about horizontal scaling in this particular purpose. What you might have to worry about is vertical. And that means more CPU, more RAM on collection and the database, because now you're dealing with larger amounts of data. You could potentially be grabbing hundreds of thousands of pieces of information from Salesforce and trying to chunk through all of that activity in some kind of reasonable manner. Again, we're not worried about real time, so the search indexer probably not worried about how slow it gets through that data. But that XConnect collection piece probably needs some extra beef. Now from here, we're going to look at the other side. Again, similar to our in-store integration, data exchange framework goes, calls search, figures out where it has to go find things, gets the data from the index, and then fills it out with data from the XDB. Data exchange framework in this scenario happens to do something else a little bit different. It goes directly to get some extra details out of XDB without going through search. So this is just a little nuance with the data exchange framework. So in this framework, we've again got the XConnect search being called, but now probably only one endpoint. We're not really worried about scaling out again. But again, how much data is it trying to pull? Is it trying to sync the whole freaking database? Looking at everything that happened within the last hour or something like that? There could be a lot of data, especially since we mentioned this is a high traffic website. So now again, we're worried about vertical scaling happening on these instances, particularly with the XDB collection database, which now we've seen on both the writes and the reads are having this issue, plus our general web traffic. And then we've got the in-store traffic. So this is where we really need to be thinking about how much power we're putting behind the server of XDB. And my favorite phase, phase 2. How many people actually get to do phase 2? Only a few times have I gotten a chance, but When you do get that chance, you get to do some really cool things. You get to start getting into marketing automation, running those plans. You get to do live personalization of content. It really does change the way the customer experiences it. But how does that impact your actual infrastructure when you start deciding we're going to do phase 2? If we look back at the services and we look at our scenario, we've got our visitor, we know that on load, we're going to get information about them, we're going to put in the reference data, metadata, and now we've got those 2 integration sources, of course. They're kitting in on XConnect Collection as well. And now we want to personalize. The only real change is, how much do we want to know when that visitor comes? We've got all the rules already in place for everything we need to do. If we've isolated for high traffic, we've probably isolated correctly for personalization. But you can configure what data you're going to load when a user visits you. So depending on your personalization rule and what data and facets you're going to personalize against, you're going to have a potentially larger load of data being loaded from XConnect. So you might suddenly have a scenario where XConnect is just not powerful enough to be able to handle the amount of data on that first load that you're trying to pull. So this is where you want to potentially think about, how are you personalizing? What's the data you really need to load? Don't necessarily load all the data. So you can make choices as developers and architects on the software side to help with the hardware. Otherwise, you got to be looking at actual hardware solutions for being able to load all that information. If we go and look at the next piece, beyond personalization, we're going to be looking at marketing automation. Now, you've seen some cool things about what marketing automation can do, but if you want to, say, personalize off of the results of a marketing automation campaign plan, you need to start leveraging things like live events. We talked earlier about we weren't really worried about what happened with the visitor data until they left. When their session ended, we'd put everything into XConnect Collection. That means we didn't learn anything about what they did while they're on the site. We can't react. So let's say a user comes in, hits the website, and makes a purchase in the checkout. We don't know about that till they leave, unless we use something like a live event, where we go and we tell XConnect Collection, here's the updated data, please send this on to the marketing automation operation. It's now going to act just like the marketing automation engine and start processing everything, just calling all the services it needs to get that done. So at this point, you can see, if you start using live events a lot, you're going to hit most of your system, and you could have a potential real performance problem on your hand. So one way you can approach this is, one, limit live events. If you have to use it, you're probably going to be looking at having to isolate marketing automation operations, giving a lot more power to be able to handle multiple requests for these live events and be able to process it just like the engine. So if you scaled out the engine, you probably need to scale out this once you start using live events. Now, what I would prefer is we let the marketing automation worker do its bit. Wait until session end. Try to design your flows such that it doesn't matter during the session. That way you can scale out that service or work job, have it do it in the background instead. This will remove the issue of a live event. The live event is there. There's times when you're going to need to use it. But if you can plan around, can we do this asynchronously, it'll wind up being better in the long run. So, we've done phase 2. Marketing goes out. Viral campaign. The unexpected is happening. Everybody's really loving it, hitting your site in numbers you've never seen before. Now, you planned for a high load, but this is just ridiculous. So how do we go about and handle that? How do we think through this scenario? Well, the first thing we're going to do is we're going to make sure we have all the horizontal we need. We're going to throw all kinds of isolation on there. We think we could handle this before the campaign starts. But as I said, there's more traffic than we thought we needed. We're past the procurement phase. We're past the planning phase. How do we handle this? Well, I go ask IT, and they say, yeah, no problem, the Jeremys say. You can get this handled. Well, everything's A-okay, except everything is not okay. Some side effects have happened. Unexpected consequences. The reason for showing this was just to highlight that you're going to be wrong. There is no way that you will actually be able to predict how the internet is going to work. Even all the historical data you have is never going to help for that one time the campaign really goes off. And suddenly you don't know how to handle it. So we need to be flexible. We need to be able to use the flexibility in the infrastructure to make sure our procurement of hardware or cloud hardware, however you want to put it, you need to make sure that it can be changed. We need to plan to be able to scale out horizontally. We want to be able to scale up vertically. We want to be able to change it on a whim, and ideally, without us even having to do it. Something like auto-scaling, where you kind of pre-program and go, look, if the load's getting too high, spin up some new instances. That's the kind of infrastructure planning we need to worry about for these type of scenarios. So don't over-provision up front. Don't go out and buy 12 content delivery servers just in case, when you know historically you have 2. Plan for what you know now. You've got your best guess. While you're planning for what you know now, plan for the fact that you're wrong. Where do you need to be worried about? Put as much flexibility into your infrastructure as you can. Make sure it can react when you need to. So I know I threw a lot at you over the last little while, but really there's 3 things that I want you to go away from here with. 1, it depends. That is okay to say. You can talk to anyone, but it doesn't mean anything if you don't say what it depends on. And that's all about knowing your scenario. Look into the particular problems that you're trying to solve, the particular features you're trying to use, how all of your users plan on using the system, and be able to plan from there. And finally, I harped on it a little bit, be flexible. Understand that things are going to change. Don't lock yourself in. Don't put yourself, like the Jeremys did, into a fire trap. You need to be able to react. Now, I know we have a little bit of time here, so I'd love to open up the floor for any questions, if any of you have any. No TDS questions like the last time I was at a SUGCON. Oh, got one down here.
Hi. I was wondering, I didn't hear any mention about the shared database that used to be from the version 8, where you used to preload for historic XDB data.
The shared session you're talking about.
Shared session, exactly. I'm a little bit new to SUGCON right now, so
yep.
I don't see what's the difference between the XDB reference database, the XDB index. It's like doing the same functionality as the session database, like pre-caching the data in the buffer.
So you'll notice that there is a session state store that's still in the model right now. I didn't talk a lot about the content delivery architecture and how all that's working. I focused in a lot more on the services. That still is in play. You still have that kind of session which captures all the information until it gets flushed out. So in version 8, that was kind of running on the content delivery server where it ran and flushed it out and sent it over directly into XDB. Now the difference is that it's going to go through XConnect. So what we're highlighting here when we're looking at that session state is really about when is it that we have to fill it and when is it that we have to send it out so that we know when those other service points are going to need additional infrastructure. In the past, it was going straight to the database, but now we have a layer in between. And we have to worry about how do we scale that layer to handle increased traffic. Previously, the planning was up the XDB as much as possible to handle more and more requests, which just doesn't scale. So now with that layer in between, that's what we have to worry about from our processing on top of the database. Oh, so the question here, just to make sure I understand, is the data in the reference database the same as what's in the shared session database? And in the index. Yes and no. So the reference data table is kind of, yeah, exactly. It depends. So it will get used to kind of fill up stuff in the session so that during session we can say, Well, I'll take a particular example. In the scenario where people are buying televisions in the store, you might have the list of available televisions with their names up in the reference database. And somewhere in the interaction, it'll have the idea of like, I bought this television or whatever. But the reference of what that actual television is and all these stats about it would be in the reference database. It's kind of a flat marketing piece. So that might get pulled into session for the purpose of personalization while you're in session, but it doesn't necessarily wind up in the XDB. So it's kind of like we've taken, XDB is a little bit lighter and is able to reference kind of commonly used pieces, particularly things like a goal, for example, would be a good thing from the marketing panel that gets duplicated over to the reference data database. So you might reference a goal, and it's there in the reference data database. If you think about it, it's like it never goes and talks to SUGCON. It only talks to itself, and so it needs kind of a copy of a lot of data to be able to reference stuff that is otherwise defined in other systems. SUGCON being one, but you might have stuff in Salesforce, you might have something else that you're referencing, and that's what goes in that reference data table. Great questions, though. Do we have another one?
Should I put 4 shards in the same SQL Server in case I need to separate them easily later? Or
like in terms of planning for how much vertical scaling you might need to do. Yeah, no, that's a good point. So if I understand correctly, you would want to, at a first stage, say, I'm going to do 4, all on one piece of hardware or one SQL Server instance in the cloud, and then distribute it across multiple servers at that point. Yes, that's a good way for you to give yourself additional write capability, additional RAM, additional CPUs that you can isolate into each one. So absolutely, that's a good way to go. The only change, obviously, there is from a shard map manager perspective. It's specifying where the servers are, so you need to make sure that's also being updated when you decide to redistribute the hardware, so that the application layer, when it talks, will know where to go.
I have a question. How do you do that in real time if you've got all that data on a server and you just need to split it across a number of servers?
Real time, you're not going to be doing it. No, that's why I was saying it's not really an easy button solution. You can't realistically go and suddenly, while the site is up, redistribute all your hardware. While you can do it, you're going to probably have to do like we do when we're migrating between versions, is have some kind of cap on, we're only going to grab this copy of the data, redistribute it across, so you're not gathering data there, or you're going to gather data, and then you're going to have to do kind of a delta and move that delta over afterwards. So yeah, you wouldn't necessarily want to say change the database structure while people are writing to it. So that's a very good point. Just to repeat so I can make sure, I think the question was, it's capturing all the data, so in the bus. Yeah, right now when it goes into XConnect collection, it's making that call, XConnect collection is writing to the database. You don't want to be doing that when you're doing something where you're actually going to take that database and move it to a different server altogether. Because you're actually going to, at some point, you're going to be moving that server physically to another IP, right? And you don't want to be having that happen while XConnect is trying to write in at the same time. So it's just a matter of being able to cut that cord at some point. And you can minimize depending on how you're balanced out, but yeah, it's definitely something to worry about when you're trying to redistribute.
I thought I saw someone over here with a question. Was there an arm move? Oh, there's one there.
All righty.
Hi, about the two-way integration, you were talking about the collection database that you would scale up and not scale out. What are the reasonings behind it? Because you can only scale up to a certain level.
Yes, so you might be looking at it from a cost perspective, for example. Maybe it's cheaper to scale out than to scale up. So the reason I made that comment was typically, when you horizontally scale and start duplicating instances, the primary reason is because you have too many incoming calls, and your bottleneck is the fact you cannot respond to the connections rapidly enough. So you need more connection endpoints to be able to handle it. It's like thinking about a load balancer, right? We put a load balancer in place so that we can distribute the traffic across multiple instances. Now, the reason I was saying in the Salesforce Connect scenario is you're in a batch. You're not worried about a lot of concurrent calls. So the horizontal scaling is not going to give you the fix for the multiple connection issue. You could vertically scale instead to handle the amount of data. Now, you could try to fix it with a horizontal scale by saying, well, while there's not many calls coming in, at least if I have multiple instances, I'm handling the vertical scale the same way. But it comes down to kind of a, you're solving, it's like, you know, do you use a hammer to put in a screw, right? It's like, it might work, but it's not the right tool for the job. Vertical scaling is for when you need to do a lot more at once. Horizontal scaling when you need to do the same amount multiple times. Yes, so you're asking, can you split up the batch? So if we're looking at something like Data Exchange Framework and Salesforce Connect, it has the capability to do multiple threads. So you can actually configure on this, that calling point that it's going to send data as multiple threads, each one of which opening connections, at which point you could take advantage of that horizontal scale. So in a realistic scenario, we're probably horizontally scaling anyways because we had all that visitor traffic coming in. Then we can take advantage of those multiple threads because we've already horizontally scaled. But it wouldn't be you wouldn't necessarily look, if you were just doing Salesforce, at doing horizontal scale to handle that. Depending on how the pricing worked out, it might not actually be in your favor. Any other questions? All right, well, thank you, everybody. Thanks so much for your time. Enjoy the rest of the conference.